All right, let's pull back the curtain on what a real-world machine learning system actually looks like from start to finish. We're going to see how raw data gets turned into a live prediction service that can forecast car sales, all through a fully automated pipeline. This isn't just theory. We're taking a deep look under the hood of a complete MLOps project. So, with all this complex tech, what are we actually trying to solve? Well, it all boils down to a pretty straightforward business question. Can we predict which Chevrolet model is going to be the top seller next month? Answering this automatically and reliably is what turns data from a cost into a real, tangible asset. So, let's check out the architecture that makes it all happen. So here's our game plan. We'll kick things off with the business problem. Then we'll walk through the entire architecture and how data gets ingested. After that, we dive into how the model is trained and served. And finally, we'll wrap it all up by looking at the complete MLOps cycle. First things first, the challenge. Our main goal here is to engineer an automated system that takes raw sales data and transforms it into a solid, reliable sales forecast. Now for the fun part, the architecture. The best way to think about this is like a modern data factory. We're going to go down the assembly line and inspect each piece of machinery, from raw material all the way to the finished product. And this factory is built on 4 core pillars. It all starts with data serving, where we use Flask to generate our source data. Then comes orchestration and ingestion, where Prefect acts as the foreman, managing the data pipeline. Next is the main event, training, with MLflow and Keras building and tracking our model. And finally, deployment, where Flask makes a comeback to serve that trained model as a live API. Let's talk about our first tool, Flask. It's a super lightweight Python framework, which makes it perfect for building small, dedicated microservices. And in this project, it's a real workhorse. We're using it to simulate the sales data source, to act as our data storage, and to serve the final prediction API. It just goes to show how versatile it can be. Next up is Prefect. You can think of Prefect as the factory's automated conveyor belt or its logistics manager. It's a workflow orchestrator that makes sure data gets from point A to point B, no questions asked. Its job is simple but absolutely critical. Pick up the data from the source and deliver it to our data lake, on time, every time. And then there's MLflow. This is our factory's quality control and inventory system. Seriously, without something like this, trying to keep track of which model version was trained on which data with which parameters, it would be a complete nightmare. MLflow logs everything automatically. It makes every experiment reproducible and gives us a central registry of production-ready models. And here's the heavy machinery itself, TensorFlow and Keras. This is the powerful engine that takes our prepared data and actually forges the predictive model. We're using Keras specifically to build and train the neural network that's going to do our forecasting. Okay, enough with the theory. Let's see this thing in action. First up, data ingestion, fully automated by Prefect. This little code snippet really shows you the beauty of Prefect. We just use a simple @task decorator to define our jobs. Here we have buscar datas de API de vendas, which means fetch data from sales API, and enviar datas para API de storage, which is send data to storage API. Prefect then takes these individual tasks and handles all the logic to run them as one seamless flow. The whole ingestion process is really just a clean, 2-step dance. First, the fetch task goes and knocks on the door of our sales API on port 8777. Then, as soon as it has the data, the push task sends it straight over to our data lake, which is listening on port 8778. It's a super clean, automated, and reliable data pipeline. All right, our data is now safe and sound in the data lake, so it's time to get to the real heart of this operation, the ML pipeline. This is where we train the model and use MLflow to track its entire lifecycle. Now, this block of code right here, this is what separates a messy, one-off script from a robust professional system. Inside this MLflow.start_run block, every single important piece of information gets captured. We're logging the model's hyperparameters, its performance metrics, the actual model file itself, and then, the final step, we register the validated model in the MLflow model registry, making it an official candidate for production. And what's the results of all that meticulous tracking? Well, you get a beautiful, clean summary like this one. This table shows the final performance metrics for a training run. An R2 score of 0.84 is actually quite strong. It tells us that our model can explain a huge chunk of the variance in sales. And because MLflow logs these metrics automatically, we can easily compare different experiments to see which model version truly is the best. So what's the final outcome? what's the payoff for all this work? Well, after all the training and evaluation, the pipeline uses the best performing model to make a forecast. And here it is, real, tangible business value. The system predicts that for the upcoming month of October, the Chevrolet Tracker has the highest sales potential. That's an actionable insight generated completely automatically. A model just sitting on a server is pretty useless, right? It's just a fancy file. It only becomes valuable when it's deployed. So let's look at how we take our model from the registry and serve it as a live API that anyone can use. This little bit of code is the magic link that connects our model registry to our production application. That model URI isn't just a file path, it's a precise, unique address for a specific model with a specific version. By using mflow pyfunc.loadModel, our application can pull the exact version-controlled model every single time. That is absolutely key for consistency and reliability in production. And here's the proof that it's live and working. We can send a simple JSON request to our API asking for a prediction for the Onyx model in October, and instantly it shoots back a response with its forecast, about 15.73 units. The system is fully operational from end to end. Okay, so let's zoom back out and take a moment to appreciate the complete MLOps cycle that we've just built and walked through. When you look back, you can see we've nailed all the key principles of MLOps. We have automation in our data pipelines, check. We have full reproducibility thanks to MLflow's tracking, check. We have robust versioning in a central registry, double check. And we have standardized, consistent deployment, check. This is the difference between a simple script and a true production-grade system. This really brings us to a final, bigger question. We've built this incredible, flexible data factory to automate sales forecasting. But now that this powerful system is in place, what else could we automate? Think about it. Inventory management, optimizing marketing campaigns, maybe even dynamic pricing. The possibilities are huge. This entire end-to-end system that we've just explored wasn't just a theoretical exercise. It was designed and built as a proof of concept by data professional Elias Andrada. It's a powerful, practical showcase of exactly how to engineer the automated, intelligent systems that drive real business value. So for any organizations out there looking to build this kind of data-driven power, from business intelligence all the way to a full MLOps cycle, this is the kind of deep expertise that makes it a reality. If you're interested in bringing this top-tier skill set to your team, you should consider reaching out to Elias Andrade.